Good afternoon, everyone. Thank you so much for joining us today for our webinar on creating safer intersections for all vulnerable road users. My name is Brooke McGee, and I am the communications representative at GRIDSMART. Before we get started, I wanted to cover a few logistics with everyone. I will be moderating today's webinar, so if you have any questions, please use the Q&A feature to send those to us. We will be answering them as they come in. This webinar is being recorded, and we will share that recording with you by email, along with a few other resources and links to some upcoming events. Justin Cox will be leading our webinar today. Justin is a regional sales manager at GRIDSMART, and we also have Pablo Torres, field application engineer, who will assist in answering questions. I know you're all excited to get started, so I'll go ahead and turn it over to Justin.
Thanks, Brooke. Hope everybody's having a good start to their week, being productive from their home offices. Today we're going to review our vulnerable road user functions within the GRIDSMART client, and then I have a couple examples of real-world videos that we'll share as well. And please feel free anytime, just shoot out a question using the Q&A section, and then Brooke will interrupt as she can to ask your question. But yeah, let's just go ahead and keep the questions flowing as they come up. No need to hold on to them. We'll try and be under our 30-minute time frame. I think last week we went a little long, or I guess it was 2 weeks ago. But this time we'll keep it right at that 30-minute mark and make sure we have time for more questions in case they come up. So vulnerable road user, we're going to define as a bike, pedestrian, or even a scooter rider that enters the roadway in a crosswalk or even a vehicle lane. Initially, GRIDSMART has created this pedestrian zone feature. We've had this for several years. Here in the client view, we can see the pedestrian zone in the configuration mode, which would be how we would create a pedestrian zone. And these pedestrian zones provide bi-directional extensions to the parallel vehicle phase. So as we create these zones, you can see a bi-directional movement. So any object moving within this crosswalk in either direction will provide an extension to the output we assign. In this case, we're going to set it to phase 4, so that way it's parallel with the vehicle phase 4. So it's the same controller logic as an advanced loop extension. So if you had an advanced loop out here and you were extending as vehicles were approaching so they can still have a green light, it would be the same thing. So we're not actually messing around with the PED phase in the controller. If there's a timer on the PED crosswalk or a red hand or red man, and those are all expired, that's irrelevant to what we're doing because we're providing an extension to the vehicle phase that's not in conflict with that particular crosswalk. So the use case here would be we've got pedestrians that need additional time to cross than what's typically allowed based on your controller settings. Or perhaps a user entered the crosswalk without pushing the button, or maybe the PED button was damaged, and they entered the pedestrian zone, the crosswalk area, and we would be able to provide extensions for that vehicle phase, so there's no conflicting traffic entering the PED zone, the crosswalk, while there's a PED in that zone. So that's our PED zone. There's lots of example use cases in the field. You can use these at hot crossings to extend reds or hold reds. There's a number of ways that these can be utilized, but in this particular case, this would be a very standard use case for that PED zone. So the next topic we're going to address is bikes, and how we address those is by creating a middle of the intersection box. Rather than doing a function at the stop bar, which we'll describe in a little bit, we're trying to create an extension for our vulnerable road users while they're in the middle of the intersection. So in this example, we've created this box in the middle of the intersection, and we'd be able to assign our outputs for bikes for each corresponding phase at this intersection. And as an object or a vulnerable road user entered the system, our machine learning algorithms that we're utilizing in version 19.3 or better will provide an extension based on demand. So as that bike or scooter rider is riding through this intersection, we're providing a dynamic extension based on their presence. So if they need a little extra time, they'll get it. If they need more time or less time, we don't need to use the entire amount. The main idea of this kind of spawned off the California MUTCD guidelines. In California, it's a law. It requires a minimum bike green if there's a bike present. If you don't have the capacity to detect or determine whether a bike is at the stop bar, you actually have to provide a minimum green time of 14.7 feet per second all the time. So your minimum green times would be higher. There's some competitors who have used a product technology that will provide a discrimination at the stop bar, which will determine whether or not the bike motorcycle is actually present at the stop bar, and then provides a minimum green time. It's really a binary function. It's minimum bike green or no minimum bike green. So our feature goes a step further and provides a bike extension based on its use case, right? If Lance Armstrong is in the left-hand turn pocket and he pushes through in 3 seconds, well, then we drop the call and extend, and we're allowed to be more efficient and move on and service the other cycles. If grandma or grandpa or maybe Sally's following daddy on a left-hand turn and they need more time than the minimum green bike phasing allows on that 14.7 feet per second, they actually need much more time. We can provide that based on their presence. So there's a dynamic difference between the way we approach servicing vulnerable road users at our intersection versus our competition. To review some of these, we're going to go ahead and look at a couple real world videos as examples, so you can see how we are actually performing. All right. In this example, you'll see vehicles drive through the middle of the box. We've got the box drawn in the middle of the intersection, but vehicles are not actuating it, only the bike. And as the bike exits, the call drops, right? The outlined blue zone is determining that there's being a call sent to the controller for the assigned outputs. Another thing to note in this field of view, just so that we're all on the same page, is that we have these phase indicators on each approach in front of the zone that shows whether we're in a green, yellow, or red phase state. So you can observe as bicycles enter and exit what the phase status is on each one of these examples. This example here has up in the top corner on this approach has a group of bicyclists moving through. You can see the vehicles don't provide the call, but as this group of bicyclists move through the intersection, they'll continue to receive their calls to extend the phase well beyond the minimum green time. And then as they exit, you can see the phase cycling yellow to red, regardless of what the cars are doing. This example has two segments to it. You'll see some vulnerable road users approach from the bottom of the screen and then also from the top. And there's a note here at the end of the next phase, as this top phase turns green, you'll see a bicyclist approach from the bottom in a red light. But even though he's approaching in a red light, we're still able to provide an extension through the box until he exits safely. You'll see him enter here shortly. Red phase, and here he comes blasting through a red light in the opposing traffic, but still gets his clearance to exit.
Justin?
Yes.
A question from Damon.
Okay.
The system learns which phase is on for the box zone and only applies extension to the output assigned for the subsequent phase?
Yeah, that's a good question. So the controller logic doesn't allow you to extend a vehicle phase that's not active. So you're only extending an active vehicle phase that's in the red or in the green light status. So if you're in the green phase status and we're extending that green, it's only going to, if we have multiple outputs to multiple phases, we're only extending the actual green phase at that given time. So we're not really mapping any of the outputs per se in our system. We're just providing that simple call, the extension call into the controller phase, but it's only affecting the zones that are in the green state. Does that answer your question out there, Damien? If you have any more follow-up, just shoot in another question. Do we have another question in there too, Brooke?
Yes, we have one from Paul. Assuming the box is omnidirectional, no need to draw directionality arrows?
Absolutely. There's no direction zones that we're working on here. It's simply you draw that zone. In this case, the zone is drawn completely inside the crosswalk. I've seen other cases where they're slightly smaller. I've seen cases where they include the crosswalk. This is probably an ideal drawing of that zone inside the middle of the intersection, not into the crosswalks. So the zones stop right there at the edge of the crosswalk and then move in. But yeah, no need to worry about directionality at all. The system is just tracking moving objects. And the machine learning algorithms that are being utilized in these 19.3 updates and greater are actually able to differentiate between the vulnerable road user and the vehicle. So that's why we're seeing vehicles move through without providing a call, but bikes as they enter are being discriminated as a vulnerable road user, and they're being provided a call onto those outputs that we've assigned in that zone. Good questions. Keep them coming. Again, if you need a follow-up on one of those questions, just type it in there. We'll get to it. So, but yeah, just take a look at this one. This one is pretty mind-blowing to me to see a user exit or enter the intersection on a red vehicle phase, but he's still safely able to cross. It doesn't matter what system you're using. If you're doing bike discrimination at the stop bar, you weren't able to provide a safe clearance for that kind of a user. Another example here, we're showing a slower user at the top of the screen with a fast user pushing through. Again, the idea here is to exemplify that it doesn't matter how fast you're going for our system. We're providing an extension based on the need or the demand, not based on a simple stop bar trigger. However, we've also seen plenty of bikes position themselves outside of the stop bar. So in those cases, those bikes wouldn't even been given a minimum green, where we're able to provide that amount of time needed.
Hey, Justin, we have another question. Can I have pedestrian zones without vehicle zones?
Yeah, yes. If you wanted to just draw an intersection with only pedestrian zone, you could do that and then provide outputs into your controller for extending those vehicle phases. Yes, that would be possible. An example of that would be maybe a hawk crossing mid-block where you wouldn't have typical detection. However, maybe you would want to exclude vehicle zones and for a particular reason, you would be able to set it up in that manner. All right. So this is the same video. The difference on this one is we're providing a graphical indicator here to show you what the machine learning algorithms are doing in the background. So in this case, as these bicyclists begin to move, we provide a yellow dot that shows, hey, our machine learning algorithm is interested in this object, and the black dot is the confirmation that it is, in fact, a vulnerable road user, and we continue to hold those extension. There's another example of that one here. You can see there's a few bicyclists coming in this way. You've got a jogger, a walker, and then there's another left-hand turn bicyclist moving as well. So a lot of activity. You don't see the dots in the client view. This is just a graphical representation of what's happening in the background and how we're determining a vulnerable road user versus a vehicle. But again, you can see again, there's two pedestrians on this kind of upper right corner, two bicyclists on the south corner, and then another left-hand bicyclist crossing the intersection.
Hey, Justin, we have another question that Pablo would like to answer. How is this programmed into a typical controller? Most vehicle extension settings are per phase, but this box is for all phases. Pablo, did you want to take that one?
Yeah, sure. So basically, the output that's assigned inside the box, I don't know, Justin, can you jump back to the client real quick?
Yeah, sure.
And then bring the box outputs. So basically, depending on what you're using, SDLC or this is a Caltrans intersection, so we're only using the 24 outputs. So if I set up 13, 14, 15, and 16, I could set them up on the I and J rack for a 332 cabinet, where I can set up advanced detection and add extensions on the controller. That's how this works. And it will be the same thing for an SDLC cable. It's depending on what BIU you want to use and what outputs on those BIUs, BIU 2, 3, 4, or 1, whatever you want to use for extension as advanced zones. It works like an advanced zone, so you're only adding extensions on your controller. That's about it.
Good question. Thanks, Pablo. And I see, Brooke, I see another question there from Joe.
Yeah. Joe asked, will this be able to count for PED movement?
At this stage, this is not going to be utilized to count for PEDs. As we improve our ability to count PEDs, the way we release that feature, may be a little different. That's not for me to review here at this point in time. But yes, at this point, the PED zone does not count PEDs. The box zone in the middle of the intersection does not count PEDs either. If you needed to count PEDs, you can draw a vehicle zone in a crosswalk, but I will highlight that at this point in time, our system does get confused with groups of PEDs moving in the same trajectory and may only count them as, significantly less than they're actually in the group. You might get a group of 3 or 4 be counted as 1, but you would have to draw a vehicle zone even to get that count. And I do know that data could be valuable, but you do need to understand that would be a limitation currently. There will be some enhancements down the road regarding our ability to count PEDs. As far as when that's available, we don't have that time frame available or open yet. One other thing that I want to bring up before I jump back to those example videos is the vehicle. There's 2 options in the output section, the bikes and the vehicles. I think I glazed over this earlier and I missed it. And I wanted to highlight a use case for the vehicle section. Pretty obvious, we want to extend vulnerable road users as they move through the intersection. But why would you want it for vehicles? Well, if you had transit or freight moving through, but you wanted to keep your minimum green time low, you can provide an extension on those. Maybe those left-hand turns on the side streets don't typically have a very long minimum green time. So we can provide a minimum green extension for a transit or freight. It's got a slow stop to start and might need a little extra time to clear. So we can provide that here in these vehicle zones. Or maybe another use case is you've got a funny shaped intersection and some vehicles kind of get stuck in the crossing before they're able to make it all the way across. You can provide an extension that way. That's a use case that I've seen in action before as well. But that would be why we have the vehicle operation here. So you've got a number of capabilities. You can do only the vehicles, you can do only the bikes, or you can do them both. All right, I'm gonna jump back over to our videos here. Okay. And this is another use case where we've calculated the MUTCD revision for California. So at their formula at 14.7 feet per second, along with the other minimum green times, you get a clearance speed of 12.3 seconds. So if this bicyclist was provided a stop bar call for a bike zone, it would have provided a minimum green time of 12.3 seconds, right? However, let's see how much time this cyclist actually needs to clear the intersection. So as it turns green, he's off. And in this case, he actually only needed 7.9 seconds to clear, which means we wasted time. Had he been the only object at the stop bar, he would have only needed 8 seconds, so we would have wasted over 4 seconds waiting for nothing. So utilizing a typical stop bar discrimination solution doesn't give you the efficiency you need. In fact, most of the roadway bike users are avid bikers, and they're mostly moving through much faster than those minimum green times. The minimum green time use cases sometimes can't even provide, in this example, enough time for clearance. So there's a left-hand turn biker. You can barely see him underneath that. He's behind that white van. Here he comes. And he's moving through. Had he been actuated at the stop bar with a bike discrimination product, he would have been given 12.7 seconds of clearance. Well, in this case, he actually needed over 16 seconds to clear. So the first example was inefficiency. We didn't provide the stop bar discrimination products, wouldn't have provided enough time for him to clear, or would have provided too much time for him to clear, and we would have been wasting time that we could have used to service other phases. In this example, it's a safety function. That product or feature wouldn't have allowed the bicyclist to clear. He needed more time. The GRIDSMART solution for the box accounts for both, right? We're able to provide the actual time needed based on the dynamic movements of those vulnerable road users in the box. So if they need more time, they get more time. If they don't need as much time, they don't get it.
Hey,
we got a few more questions here? Yeah.
Yes. And we also got another comment too from Randall, one of our field application engineers. He messaged on the pedestrian zones and vehicle zones. Having vehicle zone before the pedestrian zone helps us model traffic more accurately and reduce false calls in the pedestrian zone. So I think that was a follow-up to one of our earlier questions.
Great, yeah. Thanks, Randall.
Yeah, Kevin asked, would this system be able to see a bus as a bus and put a transit priority call? And could it read the route number on the front of the bus and place a priority call according to route number?
Yeah, good question. I know initially people we look at our system and we see that it can do a lot of amazing things. So we start dreaming on other things that it can do. No, we can't identify a route number on a transit vehicle. Although we can determine the length of objects, we're not providing additional features or functions based on that length that we're able to determine. So in those regards, transit priorities would need to be done using other technology. That's not something that we can do. Even though we can provide an extension for a slow mover, we can't provide a transit service priority call into the controller based on that object. Good question.
All right, we have a few more. What module allows me to use the box, and does this feature work for 2 camera intersections?
Okay, good questions again. So first question, this is an out-of-the-box feature. So GRIDSMART, we've determined, hey, should we charge for this? It's definitely worth some extra dollars. There's no doubt about that. Or should we just provide a standard safety feature for all of our users? And that's what we've come in down to decide, that this is an out-of-the-box feature. I think with 1910 and newer versions, we ship this, all of our GRIDSMART processors with this capability. So you're getting this out of the box. You don't need to do anything special or pay for an additional module to get this. And then regarding 2 camera intersections, absolutely. In the case of 2 camera intersections, you would draw a box in both cameras. So if I were to jump back to the client view, you would draw one zone for the first camera, and then you would come over here to the second camera and then draw the same zone with that different camera angle, and then assign your outputs accordingly.
Hey, Justin, and just to follow up with that previous question about this coming, the box feature, safety should not come at a premium, and that's why this comes as a standard. So it's not, in another module. Just wanted to make sure we added that.
Absolutely, yeah. Just the GRIDSMART principle. Thanks, Brooke. So we have a couple more minutes for some additional questions. If anybody else has anything they'd like to ask, we can get to it. We're also going to provide a follow-up session this coming Thursday at the same exact time, 11 a.m. Pacific or 2 p.m. Eastern. So you can log in. There will be no registration required. You just follow the link on the follow-up email that you'll receive, and it'll be kind of a meeting room. It'll be a little bit more casual format, although this one's pretty casual itself. But you can come in and ask additional questions or go off topic. So we've had some good discussion going on in those at previous times. So other than that, I think if there's any additional questions, we'll wrap it up. Yep, absolutely. Thank you, Joe. Thanks everybody for attending. And again, there's a follow-up session for Thursday if you want to ask any other questions that may come up as you're mulling this feature over.
And we will be following up with everyone today with the recording of the webinar, and I'll be sharing those details about how you can join Justin for the follow-up discussion on Thursday. Would like to remind you we have another webinar next week on Tuesday, May 19th at 2 p.m. Eastern Standard Time, 11 a.m. if you're Pacific Standard. And that one is Data, You Want It, We Got It. So we hope to see you there for that one too.
All right, thanks everybody. Have a great rest of your week, and hopefully we'll see you around on the next one.